I just got home from town and I'm excited. We've got a delivery. Okay, let's open this up here. I ordered a VEVOR hydraulic steering kit. It was quite a bit cheaper, a fraction of what a CTEC or BAYSTAR system would be. The reviews that I saw on eBay said they seemed to be reasonable quality and complete, and I guess I'm counting on that. I'm counting on it being fairly similar, or quite similar, or exactly the same as the C-Star. VEVOR supplied some basic information, and there are some deficiencies in it. If you'd like a little more in-depth look at the information supplied, check out my video called VEVOR-BAYSTAR Hydraulic Cylinder Comparison, and you'll find a direct comparison of the two products. One concern, you may say, hey, you're taking this Chinese VEVOR manufactured component and you're going to be taking genuine CTEC parts and a genuine CTEC part and fitting it on. There's a chance that something won't fit, but I'm trusting that the Chinese folks have been very good copycats and they've basically cloned this entire thing. This is everything I've got in the kit. We have here the helm, which is a pump. It's basically a hydraulic pump. That's the fill port, and that is a starboard side, and that's a port side for the hoses to be attached to. There are some additional fittings in here, angled fittings, so they can angle out the back if you want right or left, up or down. There are 4 studs to mount it, and they go through a backing plate. This is called a surface mount, or rather a front mount system. The dash would be right here. They also make a other type that is a back mount, and it would butt up this way into your dash. And these look like and dimensionally are similar or same as CTEC versions, but this is, of course, is the VEVOR. This is like a polyvinyl type of hose, reinforced, I think, with braid or nylon. It's marked there so you can keep them separate. There is port side one, and they use blue for the starboard. So you know what end you're hooking up to the back here. When you get back to the motor itself, you actually cross them. For an outboard motor, typically the red will actually go to the starboard side and the starboard side of this cylinder. See, they've got it marked blue for starboard, but you'd match the red to the blue and then vice versa. And it's just the way it is. With an inboard, evidently, you still would go blue to blue. It's the opposite action. So we've got a little bit of hardware here. This is the unit here. These are where you would attach with the fittings here. You have to cut your hose to length, and then these compression or barbed fittings, rather, you put together and clamp on, and then they attach to here and to here. This is cylinder. The piston is in here. So this is attached to the motor right here. Your tilt tube on the motor is right here, and it screws the screws to one side of it and holds these rods, hold it together and hold it in there, and so that this thing will shuttle back and forth. And then that pin there goes to the tiller of your motor and moves the motor. Right in here is one feature. There's a clip right here, and there are 2 grooves. If you need to make a fine adjustment, or make an adjustment that this is not centered, you're not getting equal right and left action on the motor, you can adjust the center point slightly by snapping that into a different groove. What we have is this amount of play just in the keyway, and that's a brand new key. This is the old wheel, and maybe we'd replace this wheel, or maybe I can shim it and get rid of that, but that alone isn't so bad. But through the entire cable system, if we look back at the motor as we run the wheel, we have about 1/2 spoke of rotation before it does anything. And especially when it's under load in the water, you move over 1/2 spoke and then it'll clunk and do a little tap and you get a little correction to port. And if it's going off, you need another correction. You go over here this far and then poke to get a correction to starboard. So you're doing this too much, back and forth, back and forth, back and forth, overshooting. So the plan is to convert to hydraulic steering. I removed the scarcely year-old Teleflex mechanical system. You can see the video that I did last year on installing it if you're interested. I removed the dash as well and took it to the garage to figure out how I'm going to mount the new helm. Only problem with the front mount is that it is quite long. You would end up with the wheel sticking out instead of the wheel in this case. In my case, is 2 inches, and I have problems with access with my knees and other things like that. I have to limit it to 2 inches or so from the face of the dash to the back of the wheel. I did something else. In the back then, I built out with a 2x6 actually, and I made a bigger hole in the back. So right now it's nestled in there. This is just about flush there. It's just just a hair above flush there. What I'm going to be doing is using the plate that's supplied and putting it on. I've done a little investigation in terms of how I want to orient the fittings to run the hose out the back. This is going over to the starboard side, and I'll show you in the dash. I've rounded this out with the file. There was an existing hole there. That hole is where I'm going to run the hoses out, and then they'll run down along the starboard side of the boat. So the fittings will direct the hose out and then down. So to start, and I will remember that, of course, that starboard side of the boat, the blue. I've already cracked these loose. So that's got a little O-ring on it. So does the fitting. And I think I misspoke before. This end is not, it's a different thread anyhow. You could not fit this into there. But you want to use the O-ring side. It's got the washer and the O-ring. So what you do is no thread locker, nothing. Just carefully thread, don't cross thread. And you thread until the washer, according to the instructions, and these instructions, by the way, are from SeaStar and BAYSTAR. They don't give instructions like this with the VEVOR. So in all cases, read thoroughly the SeaStar or BAYSTAR stuff. But you want this washer coming down. It says in contact. So when the washer is in contact, it means that the O-ring has compressed or just started to compress. So that is it. It doesn't want to go anymore. Oh, I forgot to tell you, before doing that, see this nut that's running forward? You back it off counterclockwise so the nut's all the way. What that nut's going to do is compress the washer against the O-ring, against the pump or the helm. So that's in all the way. Oops, sorry, no it's not. There, that's it. Now what you do is, for orientation purposes, you can back it off a maximum of 1 revolution. I'm going to put it around 180 degrees and a touch. Now I'm going to run the nut. Now I'm running the nut in against that. That'll squish the O-ring. Here's a 5/8 wrench. What I'll do once I've got that orientation, I lock it here. Now they suggest you do this before you do it on the helm, before you put it in the dash. Okay, you can't see the beam, but I can. I'm ready to make the hose attachment at the helm, and I have my whole dash removed here. And we'll go like so. I have to make the connections in the back to the swivel fittings. I've already attached them and oriented them about the right direction. So let me get in here and sit down. Before doing this, I'll show you. I just made a little template, 3.5 inch radius of this cardboard template, and that's just for show and tell. I knew it wasn't an issue here, but I thought I'd show you. These are the hoses. You see we still have the plugs in, the blue for starboard attachment on the back of the helm and red for port. They're coming up here, they're going back behind the throttle quadrant, and they're stretched out nicely, straight, no sags or anything, straight back to the motor, more or less with no, with constant slope, more or less. So you look here, like there's not a problem. We could kink them up tight, even like that. That's approaching it, but still not a problem. So we're not going to have a problem that way. When I had the mechanical cables here, the amount, the way they had to feed in, they were quite cramped. They were at a minimum radius here, and back at the motor they were minimum, and that's one of the reasons I believe we had the excess friction in the system. But now let's connect this thing. The VEVOR literature is not particularly helpful. So I default to the C-Star, and this is for C-Star helm and connections, and tells you these are standard fittings. So I mean, it's the fitting is the fitting. It's not a C-Star specific. Told me what torque to put that in, and into the back of the helm, which I think was 18 foot-pounds. On this end it goes to the hose, and it's going to be 15 foot-pounds. It's a relatively high pressure, well I guess up to 1,000 psi. That's not so great for hydraulics, it's not all that great, but for these connectors they recommend not just any old Loctite on the threads, but I believe it's the 545 or 54 540. It starts with 545, and it's a Loctite product. There is a Permatex product also that's good. So you search for pneumatic / hydraulic thread sealant, and it actually will help improve the sealing of the joints. These joints are straight threads. They aren't pipe threads, tapered or anything like that, but they seal in parallel, metal to metal. And what you do is you take this stuff, and I've already nipped off the tip, but you put on the male threads. You'll put it not right to the edge, but you'll put on the male threads, put on 2 or 3 threads worth around, and that will help seal the threads. Just so you know, this costs about, delivered to the house, about, I forget now, 40 Canadian, something like that. And so that's about 30 US, close to 30. Okay, the dash is installed, switches are in and so on. Now we're left with the helm. We'll deal with this fill port later. You know what? I better make sure that key fits. Well, I just learned something. This wheel, oh wow, the key is different size, just barely. So this is the original wheel that came with the boat. I have the original steering wheel installed, and we'll test it later once there is fluid in the system and I can put some load on it and I can check the play. We're back at the motor again. This is the part I was waiting for. It's a plate for small horsepower motors. It's a different, I guess they call it, some people say triangular plate. It's an attachment plate. This goes, depending on the installation, above or below, and then your cylinder is attached through here. Carefully pull the end cap off, just an inch or so. Do not pull it over the threads on the end of the shaft. The O-ring's going to have some resistance. Okay, it just popped off. We have to be careful. I don't want the piston to come out of the barrel here, so we just leave it like so. And you can see it's come free on this end. We're no longer, whoops, there you see, it's come free. We just have to work this off. Very good. I'm going to take these plastic bushings out. Or do I need to? No, there are plastic bushings in this one, so I don't need to take the bushings out. Here's the moment of truth. Does it fit? Yeah, it fits. Yeah, okay. Let's try this end. That fits. Okay. Make sure that's still clean. Okay. Bingo. Okay. I have a plastic hammer here somewhere just to give that a tap, but I didn't need it. The fist did it. Okay, time to reapply the screws. I have some regular Loctite. It's not sealing Loctite, but thread locker. This is a blue thread locker. Now I've summarized the torque specs on this sheet. Information is found throughout the C-Star package, and the end plate screws are 60 inch-pounds. At this point, if they're not in the right direction, you can reorient the fitting. By that I mean don't touch this T that's tapped in. It's permanent, but you don't want to touch it. But this right here, I've already done this. This is just a T where you could attach a hose, or you could attach it here. This is a bleeder screw bleeder fitting. So you could have the bleeder here, and I think the way they had it, this originally was on this side. Both the bleeders were facing to the inside. The way I want it is bleeders off here, both this way, and the hoses both that way, because my boat hoses will be coming from the helm this way. And they'll, as this moves, we'll have slack in the hose, and then tighten up on the hose as it traverses over that way to the left. Hope I said that right. Right now, I've changed these caps. This is where on the port side, we will attach the starboard hose, and on the starboard side, we will attach the port hose. And that's just the way the hydraulics work, as far as that fills this side of the piston. This whole carriage here, the whole body, when you fill this side, it will go this way, which will initiate the motor is right here. It will actually pull the motor over and you'll do a left turn. So that's why you attach your port hose right there. Fill this side, you get a left, the motor's this way, and you'll actually do a left turn. Here we are at the motor. We've got a bracket for each end, or I'll call it a bracket. This is the only one that has a nut on it, an aluminum nut, and it threads onto here. There is this little stop collar here that snaps on like a snap ring. You have a choice of two positions, the lower one here or the one here. I've already moved it. It came stock with it installed here. I moved it there based on some measurements. We'll see if I'm right, but that is to help you center the cylinder for equal left to right turns. This goes into the tilt tube here, but it will allow the cylinder to tilt. When the cylinder is attached here, it will allow it to tilt, and we want it lubricated. So a little grease. Everywhere. Back here, probably a lot of grease. If you could get some in there too, then you should. You don't want corrosion in here. Also on the external threads, they suggest you put some grease on that. And I could see it's an aluminum nut that goes onto that steel threaded tube. That's inviting corrosion, I think. So that's why it's good to have grease. Try and exclude the water. Inside this nut, it is difficult to see, but on the inside of the nut is a nylon threaded insert. When I first put this in and tried to hand thread it, I came to the resistance. I took it out and looked in there, and I thought, that thing's not threaded. It's missing threads for a few of the threads in between, but I looked more closely and picked at it with a pick, O-ring pick, and I see, oh, it's nylon. It's meant to act as a lock nut. We're going to put this just loosely in here for right now. I'm going to do the other side. These pieces are identical. The only difference is that there is not a nut on the other side. That keeps the cylinder from slopping back and forth when you actuate it. So this one, same thing. I'm going to grease it up, and I'll grease the tube on the other side as well. You see I'll call that almost a rudder horn, but that is the tiller, I guess. I'm going to grab a little excess grease from here. I'm going to slather it both sides of that. Coming up, I'm going to be talking about a washer, and you'll see a thin washer I install underneath the tiller bolt, and I talk about two washers from two kits. I ended up buying a spacer kit that I haven't mentioned before, HO5090, and for my oddball applications, some of the information was confusing whether I needed it or not, but I ordered one, and I actually got sent two for the price of one, and I had these washers and a spare tiller bolt and a bunch of other pieces that weren't for my application. So Be aware that this kit on the tables, the SeaStar tables, it may indicate you need this HO5090, and it'll contain a miscellaneous bunch of pieces, some of which you might use and some of which are not for the application, but it's a catch-all kit. Okay. There's a smaller washer here on the back. I guess I'll use that with this elastic stop nut that goes on the bottom. Well, I made an assumption. This is the original plate here, but I'm demonstrating this bushing here. I thought these two washers were separate and that we were actually going to be, that bolt when it went through into the tiller, that it would squish those and that you had to control the compression for a certain amount of stiffness. This is solid, this piece through. They're connected and you squish it down, and that's where we're going to have to torque it. And this, there's a plastic washer on both sides there, and that's already predetermined, and there is a certain amount of, going to be a certain amount of slop this way and freedom. Now you see here, we've got another elastic stop nut. I'm going to put some grease on this. This is just a pilot diameter. And from what I see online is if they haven't come off in a while and you're trying to service them, take them off, they stick like crazy and you need a puller. And they do, there is a special puller sold for these. But yeah, we'll put a little on the threads too. There is a torque spec on this. I'll just hand start it for now. And the stop nut's on. Okay. I have this pushed all the way over so that at the nut here, it is stopped. So it's all the way that way. And in general, it should be centered. I'm going to measure the rod length here and the other rod length and compare them. Now, I have the motor in center position. I have an indicator here I can use too. There's a grease zerk here which I can line up with the tiller. But more or less, it's important to line it up visually with the boat, or you can measure to some feature on the motor back to the transom, whichever way. So I have the cylinder positioned straight to the motor, and I have this right here. That's not torqued or anything like that. I don't want to do that yet, but this is up to the shoulder, and this snap ring in that groove is butting up against the torque tube. Normally that'll be locking it in place. So what we do is we measure here. We find that we have, it's a little dark, 4 3/8. Okay, let's check on this side. Oops, we see there that right here, the shoulder is right to there. That's good. We will measure. Whoops, I have to do this backhanded. That's just a hair under 4. So a total of 3/8, 7/16. Now the instructions say don't worry about it if it's 11/16 or if it's less than 11/16 difference. That means that more or less you're going to get equal travel both ways. your options are to choose this groove or that groove. This is where it originally was, and based on my estimates, I moved it to there, which was probably pretty good judgment. If I were to move it to this one, which is over 7/16 of an inch or so, it would basically shovel the 7/16 of an inch over to that side, and I think I'd be basically in the same situation. Instead of 4 7/16 here, I would have 4, and over there I'd have the 4 7/16. So I'm happy with this now. If I have to, I could make an adjustment after, once I have things all buttoned up, if something changes. So now I'm going to torque these on either end of the cylinder, and I will torque that down. After that, we'll worry about hooking up these lines here. So this nut is to be 20 to 25 foot-pounds. I don't have a crow's foot big enough to fit that, so I can't use the torque wrench. So that little snap ring in there, and this nut has to resist all the push-pull force to turn this motor with that short tiller. Well, I guess the pivot is back here. So from here to the pivot point here is about 9-10 inches. So that's actually a decent length of moment arm to give you some authority, but still there are some significant forces, especially when the boat's under power, and then when it gets battered back and forth. There, I feel it snugging. We've made there, so you'll notice here on the port side I have a 12-gallon tank. And what with the original mechanical steering cables, I could not put a 12-gallon tank on that side. So I made do with a 6-gallon tank. So we had a total of 18 gallons, and that gives us, we burn get about 6 miles to a gallon. So anyhow, that's how we had it. Now, at the very least, this is what I want. So when we arrange these, I want to be able to put the 6-gallon in. That's 36 pounds. 6 pounds a gallon, 36 pounds of fuel on that little one. Okay, well, it's just still got some fuel in it. This is the 12-gallon. It's 72 pounds when it's full. So you have to wrestle it out of the boat and get it and use a cart and go to a gas station, or you can fill it at a marina. But you can see it fits nicely, and the other cables work okay. So this is going to be in here for calculation purposes. I got the 24-foot kit was cheaper than the 20-foot kit, and the 20-foot kit would have been iffy. I don't think it would have made it. I needed something like 22. So yeah, buying a 24-foot kit, no problem. Get free hose for, I forget how much it was, like $30 or $40 less. It must be because it's a high runner or something like that in terms of volume of sales. I don't know. I've marked with zip ties the lengths I want to maintain. One is shorter, because it goes to the near side of the cylinder and the other goes to the far side. There's 9 3/4 inches difference between the two. I've allowed some length, and the fitting itself that is used has some length to it as well. From here to here, it adds about 1 inch. I'm going to be cutting on the long side of this because who knows if I make a mistake. But before that, I have no experience cutting through this stuff. I don't know if this is going to be adequate. I see, or whether snips. I see people have used different instruments and basically cut through it. You want to cut through it anyhow. You don't want to saw through it. If you saw, you make fuzz, you make particulate matter, which is dangerous for hydraulic systems. You can mess things up. So what I'm going to do is, I'll throw that one down. I'll try cutting. So this is rather flimsy, but this can cut rigid PVC. Sometimes you have to actually do this. It's pretty rigid. There, it just crunched through. It's making a little bit of fuzz. We don't want the fuzz in there. See the fuzziness? That's the nylon layer. The inside is, so there's a plastic lining and then the braided nylon and then a jacket on the outside. I'm going to try now to cut with this. Man, that is not so good. Those don't have the oomph. Let's try the utility knife. I'll cut on this end right here and we'll see how it goes. I chose my lightest utility knife to bring out here to the barn. It's cutting, that's nice. Sort of sawing through it, but I'm just, I think it's going to be a clean joint or a clean cut. I'm rotating it slightly as I cut through it. Yep, it's a lot cleaner. So if I had a heavy duty one of these perhaps, but it squishes it when I start cutting. So this is pretty clean. So the wee utility knife wins the competition. Okay, I'm cutting the short one. It's the one that was hooked up to the port side of the helm, the red side, and it hooks or attaches to the right side of the cylinder. I'm cutting it about 1 inch longer than I think necessary. Utility knife was not up to the task. I ended up getting a bigger one to cut it through, and it did cut cleanly on both hoses. Okay, I managed to get through with the utility knife and I got a fairly clean cut. I've got this fitting here. I'll take it apart. I'll take off this zip tie. Okay, put it on until bottoms, push, turn. I did not need a wrench for the other one. It doesn't seem like I will for this one. My hands are oily, so I can look inside and I can see it still needs to come a little over 1/8 of an inch. Oh yeah, and I felt it bottom. If you keep turning, it does, you could keep turning it, so you could overturn it. I'm going to go lubricate this. I have a little bit of oil spilled from the cylinder. So here we go. The tapered end just gently goes in, and this threaded part, not that, that's just a spinny nut for attaching to the cylinder, but down here is a little area with flats. But so far it's just turning in with finger effort. It gets a little tighter, a little tighter. It's biting into the white inside layer of the hose. What is this? This is an 11/16 wrench. It's actually a little big. Whatever the next millimeter size is down for 11/16 is what it should be. I don't have out here in the barn a good set of metric. I just have a few different ones. So this one, the flats, are 12. So you get a 12 on there. I tried a 1/2 inch and on the other one, and it would slip off. Once you got significant torque, it would sort of smear the flats and fall off the flats. So we're just screwing inside there now. You see there's a little bit of a gap there. There's still 3/16 of an inch, or a couple, maybe 2 millimeters to go. A little more to go. We'll go till it bottoms. Okay. Actually, did a bottom on the width of the wrench, so I'm going to have to back that off a hair. So I skinnied up the wrench, and we're not actually torquing it. We are just running it down to seat and tight. There, I got another 1/8 turn out of it. Now we see this nut has an internal thread, a female thread. We're going to clean it. Let that drain a bit and dry. This is just brake cleaner. And we will do the same for this. I won't be mixing up these lines because they're cut to length. They'll only fit on one side of the cylinder. So I know which goes to the port and which goes to starboard already. That decision's been made. I don't have to worry about it now. I'm going to clean these threads. Because we will apply some special pneumatic hydraulic thread sealant. And that's the stuff that I paid $40 Canadian for 10 milliliters. It's expensive stuff. But I want to make sure these joints are leak free. These are called, these are JIC 37-degree flare fittings. There's a taper on the inside here, and there's a male taper on the inside of those hose fittings. So I'm going to clean the other one as well. Okay, that one's going to go, whoops, that blocks your view. That one's going to go right there. So, if you can see, I'll do this one here. We've got the 545 Loctite. We've cleaned the joints, and put some, we don't want to get it on the end, but we'll put some around. Yeah, it's a hazardous material, but it's wet enough that it actually will wrap around. There, we've got a generous amount on the threads, all except for the leading thread. This is the long one, yep, okay. We'll hand start this. There, it's going. The snarly hose wanted to turn a different direction than I wanted to go. Okay, so 15 foot-pounds. Make sure I read it on the right scale. Okay, that made torque. We actually got some motion there. No. Well, the next step is to wait till tomorrow. I have read, I don't think everybody does it, but I have read that that sealant should have 24 hours. And I'm pleased how it went so far. One thing that I have not checked is the way everything is. If you met the dimensions for well depth and for width. Well, the width is more for assembly purposes so that you can get these pieces in. But if you met the requirements for depth, you should have no problem. But we want to see how the cables go. And that's... One note, when we do the bleeding, we want to be in this position. It's time to fill the system. With the VEVOR cylinder, they gave this handy little hose, and it wasn't long enough, so I spliced in a piece, but it's to go between the two bleeders. If you read the C-Star information, they just say when you do the draining and the bleeding that you just pump through fluid through a hose you attach and then you put it in a bucket. And then you do the same on the other side. And you have this fluid that you have to either dispose of or try and make sure it's clean or filter it and put it back in a bottle for next time. Sort of a waste. So this tubing basically allows you to turn the wheel one direction up there and it pumps fluid, say in one side here, and it'll go the path of least resistance. It'll push through into this bleeder and return on the other side back to the helm. I'm going to put it to one side, and then we're going to, so it's as if it's in a turn to port right now, left turn. We're going to then start filling by turning the wheel to the right. We're going to be pumping right, a right clockwise turn, clockwise on the wheel up there, and that will fill the side. We'll start seeing fluid pump through, air bubbles, and returning. Once it's going through completely clear, no bubbles, then we'll close the bleeder and we'll turn the wheel right, and that should pump then this thing this way and then start bleeding here, and we'll have sucked in or pushed in stuff into here. Anyhow, in the end, it ends up being an iterative process. Once you have both bleeders cracked and it's substantially filled, you're just going to turn the wheel all the way right, all the way left, all the way right, and you're going to be letting the air bubble out of the system. Now we're going to go look at the helm and see how you actually fill in the procedure there. These are cracked loose, these bleeders, and I have these plastic containers here just to catch any drips. By the way, this happens to be on the system as 5/8 for the bleeder. We'll keep that wrench handy for when we need to close it off. Okay, I'm going to start. We're in a turn to port, and we'll be spinning the wheel to the right for a turn to starboard. Here's the helm. I've taken out this plug from the top. Right here is C-Star hydraulic fluid. There are many equivalents that they mention. VEVOR is very vague in what they specify. It's a very light watery oil, and that reduces steering effort, and it also will bleed a lot better. This is supplied with the VEVOR kit. And that is, oops, there, that's attached. This is a threaded fitting here. You know what's going to be easier? I'm going to put, oh no, this has got to go on first. I can't invert this. Some kits you can buy or equipment have quick disconnects and things like that. This does not. There's an O-ring seal. I'm going to twist that back counterclockwise a little bit, so I can get it to start in here. The O-ring seal, I can do it finger tight. It's an O-ring seal. There, I feel it bottom. So what I've done is rig this, and whoops, this goes up like so. Whoa. And that is, whoa, 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 whoa. Get that lid does not hold very well. Those threads are crappy. I made some corrections here. I used Teflon tape underneath there very carefully. It's plastic on plastic, so we're not going to be cutting shreds of Teflon tape that we'll get in the system. And I was very careful to keep it in the lower threads, but that was enough just to tighten it up and seal it. And then I put electrical tape on for a mechanical connection to actually hold it. So let's try this again. Take two. Now, as I invert it, I'll be very careful. Yeah. Now it's flowing. You can see it running down there. This thing up here, this bottle becomes airlocked. So you can either use a thumbtack or a knife. I'm going to put just a little cut to start. Later on for the second bottle, I'll use the knife to cut an opening in the bottle so I can just pour what I need, just a little bit of this, a partial bottle in. And that way I'll still have that bottle to store. I don't want to put a hole in that bottle, and I don't want to have to mess with this tape and all that stuff again. I'm having to squeeze the bottle. It's not flowing. Okay, I've put in a fair bit of fluid. Watch the tube down here. I see some fluid in it. There's air, and then liquid in the lower part. There's air. Okay, there was a big gulp of bubble or air, and it emptied the tube, and now I've lost prime. That's the problem I'm having, is if there's too big a burp, it loses prime. I've been having trouble keeping the flow going here. It seems to just be airlocked. If you end up with the lines partially filled, and then you let it go dry here at the helm end, then you just got that big clot somewhere in the line there, and you have to prime again. So what I've done is I would crack that loose just a little bit. I'd cover the top again. I just squeeze and pump until I got some fluid level. In this case, what I did was to get that fluid level to help get it back up. That's why I moved the motor back to that position, and it pushed some fluid back up through. Now the pump is primed, and I should be able to go. Now you see the level going down? This doesn't, see the level going down? This doesn't seem to flow as freely as what I see online. And one of the reasons might be that in here they actually have a mesh screen filter and a very small nozzle tip, so there isn't a whole lot of flow there. I really don't know, but that tells me the reservoir is full. Also, the other thing is when you're cranking the pump, the helm quietens down. You don't hear the rattle noise. It means that things are full. So turn slowly. Don't let that drop down into the pump or you'll lose your prime. Now that looks pretty full from there to there. And I'm going to keep pumping, and hopefully that air will force itself back up to the helm. So I'll keep going with clockwise. So there, I poured in half. It's about 1.5 inches above. It's sucking down. It fills very slowly. I think that screen is the problem. I'm not going to take it apart just for that. What I have done is cover there, squeeze, release, squeeze, release, just to fill that tube a little more. Okay, now it's flowing here, so it was a pressure lock. So it's flowing and I'm pumping, and I can pump at speed. Have you seen any bubbles? Yeah, there are still bubbles. I ideally like a second person here, because I don't know whether the bubbles are clear yet or not. I go by feel. But here is what's happening here. With bleeders both open, this is flowing, the pump is sucking. Whoops. I'm shaking that bubble just to encourage bubbles that come out, because I don't want to pump it down so much that it suddenly takes the gas and it loses its prime. I can feel it load up now with effort. This whole time I've been turning to starboard, and then I can feel resistance. I know that it is full starboard right now. I'm just pushing again. It gets hard, so I know, but a little spongy, so I know I'm pushing hydraulic over air. So what I'm doing now is going to port counterclockwise, and she's sucking stuff. At this point, both bleeders are cracked open, and I'm going many turns, half a dozen turns at least one way and half a dozen the other way. I give time for bubbles to rise. Every once in a while you can feel something different on the wheel and you think, okay, a burp is coming. Sometimes they come without warning, but that tube is completely full up to the bottle, so I know I'm not sucking air. I've cleaned up the excess oil, and I've made sure the bleeders are tight and clean, and I don't seem to be leaking anywhere. There's something I've got to wipe off. That's still from bleeding. I'll monitor that. Check the motor. It's pretty tight. We've got a little bit of lost motion there with the bolt to the bushing, and this bracket to the caps, just a tiny bit there. There's a little bit of lost motion in the helm, not too much, about this much, before the pump actually does anything. There, that's motion, and that's moving the back. I found that I have about 4.5 to 4 3/4 turns per lock. There's full right. We'll go 1, 2, 3, 4. There's about 4 3/4. And so I know if I go back 1, 2, and maybe 1/4 or 3/8, that's center, and actually the motor is centered right there. So I seem to have more or less equal action on the motor both ways. The 4 3/4 turns, that's probably more or less due to the mechanical setup for this motor. It's rated supposedly, I think, at 5.1 turns per turn. Well, that's based on volume and the size of the piston, but we may be constraining the piston through somehow through the setup. I'm not really sure. It's good enough for me though, and the effort, the main thing was effort is smooth and even, and my poor hands and wrists are going to appreciate that. The final step was to do some tests in the water. Everything was just fine, quite satisfactory, and we were ready to go on a trip, the Erie Canal and up Lake Champlain and on our way to Montreal. We did have some problems though, and that's part of the subject of the next video. Next video is actually talking about problems with the VEVOR cylinder leaking and a comparison to BAYSTAR, the competitor, the OEM. So check that video out.